All right. I'll wait a little bit till you're all settled at home and then get your notes out. With this type, you will need to determine a third point in order to perform a regression. It is best to create a sketch labeling the points provided by the text. Use the axis of symmetry to find a point across your starting point, usually the y-intercept. Starting point is on the ground versus starting point is off the ground. On the ground, off the ground. I'm going to do that side by side. Put some points down as well. I'll get you to this point and then I'll add some coordinates, okay? So just, I'm focusing on those big dots, right? Okay. So here, obviously, if you're starting on the ground, then it's 0, 0. And let's say we had 5, 15 up here. So normally the question will give you the start, sometimes implicit, meaning like ball is kicked right on the ground, right? Kicked up from the ground. So then you know that 0, 0 is your starting point. It might say that after 5 seconds you reach the maximum height of 15 meters, and then that it'll just leave it at that. It's like, wait a minute, I have 2 points, I need a third one, right? And so that's where you use your axis of symmetry, right? Axis of symmetry goes right through like this, right? So you know that if this is 5, right, from here to here, it will take another 5 to get you to that, right? 5 to get to the middle, and then another 5 to get you to the ground, right? So this is our x-intercept, which would be 10, 0. And you can essentially always take this value and just, sorry, it's going to be, right? You can just times it by 2. If it's on the ground, you times it by 2, and then you have your x-intercept there. You can look at it that way, or you can just say, hey, I know it's 5 to the middle, it'll be another 5, so let's just add 5 to the existing 5, and then we get 10. Okay? But what if on the other side, like it's saying like you're sitting on a balcony and you're throwing something up in the air, right? Obviously, we're now going to be, let's say we're at 0, 3, for instance, right? It's just a sketch, 0, 3 to start. And let's say you reach the maximum height of 515, right? Actually, let's change this because otherwise you're going to think it's the same. I just decided to introduce this. I normally don't, right? But I think if I talk about it right away, I'm going to eliminate a lot of grief down the road. So after 6 seconds, you reach a maximum height of 15. And this is where a lot of students, they mix these two up. So they'll just say, oh, it goes from here to here 6, so that means that this is 12, right? Because you just told me just multiply the x value by 2 and then you have your x-intercept. But it's not the case. You know how both of these are at the same height? Same y value of 0? Are these two at the same height? No. So you can't do that. You can only do it with something that is at the same height. So when you're starting off the ground, you're going to have to go straight across to the cousin, right? This is its cousin on the other side. And then you can say, hey, what is going to be this point here? I know it's going to be 3 because I started with 3. I need to end up with 3, correct? And if it takes 6 seconds, so I'm going to do my axis of symmetry here. If it takes 6 seconds to get to the top, it will take another 6 to make it back to where I started. 6 and 6 is 12. So you basically took this and multiplied it by 2. This is the exact same property that I talked about earlier in the unit when we did the axis of symmetry. Remember x1 plus x2 divided by 2? It's the exact same thing. x1 is 0, x2 is unknown, x is 6. If you did the math, you would come up with 12 as well. But you don't need to. This is all I need, a sketch like that on a type 3 scenario. Right? How about this? X-intercept is unknown. Need equation. I hope you remember that, because quite so often students put 12 0 or something, they put it down here. It's like, no, you started here, so you got to go straight across. It's unknown here. You need the equation to come up with it. In this case, you didn't need to, but here you do. That's the big difference. Okay, let's do an example. You throw an apple core up, come on, while sitting on a balcony. The balcony is 6 meters above ground. You estimate that the core reaches a maximum height I'm going to move it up, reaches a maximum height of 13.5 meters after 2.5 seconds. Determine the quadratic equation modeling this scenario. B, how long did it take for the core to land on the street? I'm not suggesting you do this, okay? I just thought it would be interesting to do this. State the domain and range. Oh, this should have a question mark, right? B should have a question mark. Yeah. Was it the 15th? 15 to 17. 15, 16, 17. We good? So you should recognize this as a type 3 because they're not talking about profit, right? No maximum profit, no fencing, and they kind of vaguely give you some information as to where you start off, how long will it take. So these are not all the same, by the way. You have to sketch it and see what you get out of that. Okay, so for A, sketch. Where you come up with your equation, sketch and identify 3 points. You need 3 minimum. Okay, so you just rough sketch like this. We know that this is time and this is height. And we're not starting on the ground. We're starting somewhere off the ground. So make sure, right, that you're at 0, 6, because you're sitting in your balcony and you're throwing up that apple core like this. And you can just imagine, right, the trajectory will look like a parabola. Okay, so over time, this is what it's going to look like. And we're told that we reach a maximum height of 13.5 after 2.5 seconds. Now you have to be careful. Watch how it's worded. 13.5 after 2.5. So a lot of students put down 13.5, 2.5, right? But it's time that needs to go first. So it's 2.5 seconds, and this is the height. So just make sure you don't mix those up. Okay. So this is a scenario where you're not on the ground. So you're just going to go straight across, arrow pointing towards your cousin, right? Okay, 0, 6. So we know that we're at the same height, so we can confidently say that our y value at the other end will also be 6. And what's the x value going to be? It's going to be 2 times what it took to get to the middle. Because remember, this is your axis of symmetry, right? And that x value tells you it took 2.5 there and another 2.5 there. So essentially twice that. So that's 5, 6. This is your third point. And remember, I'll do this. X-intercept is unknown. Exclamation mark. Okay. So let's come up with the equation. So this is what I would suggest, right? You have your x and your y column. Put the points in there, 0, 6, 2.5, 13.5, and 5, 6. And if you don't see this, right? If you don't see that you end up at the same height, you know you made a mistake, right? So let's say you make that mistake, you're busy, you're like, oh yeah, 5, 0, 5, 0, it's double the x value of the vertex goes here. It's 5, 0. So it would be 0, 6, 2.5, 13.5, 5, 0. And you would have all 3 different values here for your y values. So you know you made a mistake. Okay? Same height. That's good. Okay? So stat, calc, 5. We put this into L1, this into L2. We're going to come up with our equation. So let's go 0, 2.5, 5, 6, 13.5, 6. I'm just going to go to my home screen and see. I probably did a regression not too long ago. There it is. The only problem with this is if let's say we do a bunch of other chapters and you haven't done one of these in a while, you're not going to have that in your history. So don't forget how to get that, right? So there's my equation. It's negative 1.2 x squared plus 6x plus 6. And which is my initial height, right? It makes sense. So there you have it. B, how long did it take for the core to land on the street? Find X-Intercept, right? So y2 is equal to 0, second, trace 5. So I'm going to graph this thing. Probably not going to see anything. So I'm going to go zoom 9, provided that plot 1 is turned on. I can go zoom 9 after that, and there it is. However, I want to see my X and my Y axis. I'm going to go window, and here just change it to small numbers, just -1 or something like that. Otherwise, it's going to show a lot around. You don't want that. Oh, I still can't see my, so I need to change my, not my Y max, sorry. I need to change my X max to 10. I think will do the trick. And there it is. Now we find it. Go closer to it, enter, enter, enter. So it's 5.850. So at that point, right, when the height is 0, right, that's when it's hitting the ground. So it took 5.85 seconds to do that, right? It will take 5.85 seconds. C, state the domain and range. Domain is your time. And so it's from 0 all the way to the 5.85. And my range is my height in this case. And that is 0 to the maximum height, which is 13.5. I'll just remind you, domain is 0 to X-intercept. Normally, in general, 0 to Y value of vertex. Normally, okay? And let me see in that booklet. There's a page. So this is your homework, page 22 to 25. And they're all somewhat tricky, all right? So this is in your booklet. And I made these worksheets especially to assist you in navigating these little nuances, right? There will be things coming up that you'll be like, what? How do you do this, right? And so make sure you go through that. I will AC you on this tomorrow, just an AC, just one question on this type. And then on Tuesday, we're going to do the quiz on all 4. So 0, 1, 2, 3, 4. Sorry, 0, 1, 2, 3. I'm making types up as I go. 0, 1, 2, 3. Make sure you take some time and have that on your study sheet. Have a represented section for each type so you know what to do, especially fencing. I think that one is the one that most students struggle with. Okay.